So, hello everyone. Let me just find my clicker. So, yeah, what I decided to talk about today is a small library, but very useful. It's called zone.js, and today I'm going to show you what kind of functionality you can achieve while using it. And I'm also going to give some real cases that you can actually use it for. So, about me, as you already heard, I'm a Google developer expert in Angular and web technologies. I also am a co-founder of a small company. We basically develop web applications using JavaScript only. And mostly we use Angular, but we also like to be not left behind, so we are kind of researching into web components. We are also doing React and stuff like that. So we don't want to just be stuck with one technology. We try to use everything that is new and shiny. And I'm also a lecturer in Sofia University in the Advanced JavaScript course. And from time to time I do contracting, public and private courses. So I'm very active in the JavaScript community here in Bulgaria, Sofia. And yeah, I'm also involved in Angular Sofia and SofiaJS. So if you haven't joined these groups still, I suggest that you do it because it's very helpful to have a big and healthy community so we can help each other and grow together. So first of my talk, I will basically present something that a lot of people who claim that they're JavaScript developers say that they are developers, they are using JavaScript, but when I ask, okay, do you know what event loop is? And they're like, not exactly, I cannot explain it. So here I'm just going to start with this, explaining what the event loop is, because without this, we're not going to actually understand what zone.js does. So how many of you here know what event loop is? Okay. Well, hopefully after this talk, you know it. So, if you look online, you're going to see an image like this. Basically, on the left side, we have something that it's called macro task queue or callback queue. I mean, you can find it in different names, but for zone.js, the terminology is macro task queue. And pretty much when we start executing some JavaScript in the browser, we have some functions that enter the stack, and at a certain point, we kind of dispatch some kind of an async operation. In this case, it's kind of a set timeout. And this timeout basically takes a callback for the first argument. The second argument is time. This callback needs to be kind of returned to the stack after. And the JavaScript engine basically gets this callback and continues processing our application. At a certain point after this timeout finishes, this callback gets pushed to this macro task queue. And whenever the current stack finishes, the event loop starts, it spins, gets this callback, and pushes it back to the stack so it can get executed. As most of you know, JavaScript is a single-threaded language, and this is the way it actually can perform multiple operations, and it's very fast. So let's say that in this callback, we are calling another function. So this function gets pushed to the call stack. And inside this function, we're doing something like this, promise resolve.then. So most of the people, because I work with a lot of students, they don't actually know that there is a separate queue. And this queue is called the microtask queue. And basically, these are async operations that are going to be executed as soon as possible, meaning that whenever the stack finishes, even before the event loop reaches to the macro task queue, it will check to see if there are microtasks to get executed, and it will execute those tasks. So this thing gets pushed there, we continue with our program, and here we have another set timeout, or some other async operation. For example, here we have a set time with 0, which means that this callback will get pushed, almost immediately to the macro task queue. and then the event loop will basically get the task, which is from the macro task queue. It will execute it. Then it will get the task from the macro task queue. It will execute it. And then we have another queue. And here we are actually calling the request animation frame. Basically, these are callbacks that are executed just before the browser is re-rendering. So here, this callback gets pushed to this queue. It's called the request animation frame queue. And a few moments later, after the browser decides that it has to re-render things, the event loop will just spin. It will get this callback, and after that, it will just execute it. And if we have, so for example, a macro task inside, it will just get pushed to the macro task queue, and after the call stack finishes, it will get executed. So this is very important to understand that we have different queues, and these queues have different priorities, and we have different tasks. So here are all the tasks. For example, the micro tasks. This is just work that needs to get executed as soon as possible, meaning before any re-rendering or I/O operations, when you're, for example, talking about Node.js or something like that. We have the macro task queue, which is the default operations that we use when we're doing async JavaScript, for example, set timeouts or set interval or stuff like that. And we also have the event tasks. The event tasks are pretty much the tasks that you use when you attach an event listener for a certain event or something like that. They are different because they actually can be canceled, meaning that you can actually do event.stop immediate propagation or something like that. So it's not sure that either if they'll be executed or no. So this is very important to remember this. Hopefully everybody understood the different tasks and the different priorities of the JavaScript engine, because we're going to start talking about what are zones. So basically, if you check on Google, you're going to see that a zone is kind of like an execution context, and it persists across asynchronous tasks. So this allows the creator, us the developers, to be observing and managing the execution of our code in the different zones. And this is very, very useful, and it's very powerful. So why do we need it? Well, these are just use cases that I found on the web. Basically, for example, Angular uses zone.js to see if there are any changes basically if there were any changes between after the application was re-rendered, and if there are any changes, for example, a macro task happen or a micro task happen, it knows that something needs to be re-rendered, right? So at the end of this presentation, I'm going to show you a demo that I just developed before the session. And it uses web components. And as you know, like if you actually wrote with, if you develop software with web components, you don't have, for example, change detection out of the box. So I'm just going to show you how I implemented it by a few lines of code using zones. So hopefully it's going to be interesting for you. Another thing that we can do is actually we can enforce that no tasks are scheduled. This is done, for example, in testing frameworks, and this allows us to kind of control time. For example, if you have certain async operations, for example, like calls to a server or something like that, when you're using zone.js, you can actually say, okay, you're not actually going to be calling the real XHR request or the real fetch API. I'm basically going to change this, and I'm just going to push this call back to an array. And after, in this current stack, I'm just going to iterate over this array, and I'm going to give the result back. So this means that our tests are going to become isolated, and they're going to just become faster because we don't have to wait for asynchronous operations. So this is a big win as well. And another thing, for example, when we're working with testing frameworks, we see that like sometimes we have multiple async operations and we have to kind of wait for them to complete. Well, testing frameworks can use zone.js to track how many asynchronous operations we have in our tests. And we don't have to explicitly, for example, call the done callback that is returned from the framework, because the framework knows how many asynchronous tasks were dispatched, and it can automatically discover when this test finished. So this is something that is really cool. We also can have long stack traces. So probably if most of you are web developers or been using JavaScript, you know that for time to time it's very hard to track all the async operations that happened. Well, using zone.js, you can actually do this, and when something like blows up, you can have the whole stack, you can have the whole trace, and it's going to be better for you to understand what actually happened. And one other thing is that you can measure latency for users, so you can do kind of profiling. For example, if the user clicks a button, because you are actually in a certain zone, you can track how much time did it took for example, this data that was actually, a request was sent to the server to get back and to get re-rendered. So it's pretty useful for profiling. And there are many more use cases. One of the reasons that I'm talking about this, because in my company, we're often trying to solve complicated problems with managing asynchronous operations that are sent from different parts of the application. And this is very, it's very hard. I don't like when we have to put a lot of boilerplate in our code base. So we're always trying to figure out elegant solutions, and we are kind of like working on developing a solution that will just be much better than the ones that we're using right now. So let's start to see how actually zones work. So it actually, the zones library, when you include it, it monkey patches all the browser's asynchronous operations, if we're talking about the browser. If you're using it in Node.js, it just monkey patches all the async APIs. And I don't know, but probably most of you, or maybe you know what monkey patching is, but I'm just going to show you a quick example. So here, what we are doing, we are getting the set timeout. This is the original set timeout from the global object, and we're just keeping a reference in this variable. And then we just say global set timeout, and we change it to a custom function that, for example, has the console log there, timeout was called, and inside it we just call the original set timeout. And probably you guess the result, we get timeout was canceled. Not canceled, timeout was called, and then we see the hello there. And this is very cool. JavaScript gives us a lot of power when it comes to stuff like that, and this is why I actually fell in love with JavaScript, because we can kind of change everything in different ways. So we can think of zone.js as some kind of a proxy. It basically stays in between our application and the browser. And if you have been working with JavaScript proxies, you might find similarities. But yeah, it pretty much is just like a proxy. So how do we work with zones? We're going to start with a simple example. Whenever you actually load zones in the browser, you get this global object called zone, and you have a root zone. This is the zone that actually monkey patches the whole environment, all the async APIs. And from this zone, we can actually create our own zones. So here, by using the fork method, we actually create a new zone called myZone. We give it some properties, as you see, for example, user is set to no, debug is false, for example. And if we want to run something inside the zone, we just use the run command, and we give it a callback. Inside this callback, we can access, for example, the name of the zone. We can get certain properties from the ones that we actually put from the previous slide. And yeah, it's really cool. Actually, this is very useful. Before, when I first heard about zones, I actually started developing this test application. It was using Node.js, and I was actually using different zones for the different authenticated users, and depending on which zone the current request was, I kind of changed the behavior of the API. So it's really interesting. So let's see a more complicated example. Here we have the same case, but inside my zone, I create another zone. And as you see, I change the property user to some actual user. And when I run something inside it, as you see, I can get the same stuff, but I also inherit the properties from the parent zone, which is very, very handy. So you can use these properties to kind of do some kind of communication between the different zones and just share certain variables. So yeah, pretty much you can think of the zone as an execution context that is attached to a current stack frame, and they're interconnected. So it's really cool. So a quick summary. As I said, you can think of the zone as an execution context. The zone, actually, the data that is attached to the zone is shadow immutable. And once the zone is forked, you cannot touch this data. You cannot change it. And zones can inherit properties from their parent zones. So yeah, we can use it as communication. So this is really cool, but how is this, like, what else can we do with these zones? Well, we can do interceptions. So inside this configuration object that we give inside this fork method, basically we can, for example, give a hook, and this hook is called onInvoke. This means that every time this zone is invoked, we have this function that is going to be called, and we have these properties that we can kind of use and, for example, change the behavior of the operation. So what I'm going to do here is I'm going to take the performance method that is from Node.js, and I'm going to say, I'm going to measure the performance of this operation. So I'm going to say, I want to take the time now. Then I'm going to use the zone delegate. So I'm going to explain what the zone delegate is. Basically, we cannot interact directly with, for example, the parent zone or something like that, just because we don't know what the parent is going to be in execution time. So basically, this is calling the same method that we actually code in our code, so it's not something very hard. And after that, I just say, whenever this is done, I'm just going to get the end time, and I'm just going to say how much time it took for this operation to run. And inside my timing zone, I fork it. I say I want to run this code inside my timing zone, and then I just log it. And the output is, for example, hello world, as you see, and then we have the duration of how much time this took. So this is really cool when you want to like measure performance, and I mean, this is going to, for example, if you put all your code inside the run, as you know, as you saw, not probably, but it's going to calculate the whole performance of your application. So interceptions are really cool. Basically, these are the methods that we can use. It's onInvoke, onIntercept, and onFork. We can intercept, for example, and use the delegate to actually call the real method. So pretty much the delegate, what it does is that when we are using the run here, it actually catches this event, and what we put inside is this method that we actually give it here. So we just call the real function that was passed, pretty much. So, yeah, we cannot use inheritance. For example, if we want to be extending a zone, this is because the zone current is a dynamic property, so we cannot just use it. And that's why we have to use the delegates. And pretty much we cannot call a parent method just because of the same thing. I mean, if we call a parent method, basically we're just going to change the zone that it was executed, and we don't want to do this. We want to keep it as it is. So it's not, this is like the only way that we can actually communicate. So what are the benefits? Well, we can compose zones. We can observe the task execution, and we can have some kind of a centralized error handling. So these are all plus for us, of course. So how can we schedule tasks? We saw that we have different tasks, so how is this working underneath? Well, let's say that we're going to see how, for example, I'm sorry, how, for example, zone.js monkey patches the set timeout. Well, they say something like, okay, the global set timeout is going to be this function. We get the callback, we get the delay. And inside here, we're going to say zone. We want to get the current zone. We want to schedule a macro task. And inside this macro task, we're going to give it a meaningful name. So whenever we're debugging, we can actually see what the name of the task was. And here, we can actually give it a callback. This callback will kind of overwrite the default callback that we gave to this task. And as you see, I'm just going to put a console log there so we can know what's happening. Here, you can pass additional data, but I don't need data for the task, so I'm just going to pass no. And here, I have, it's called, it's basically a handler that is called just before the task is run. And here, I can call the original setTimeout method, passing it the task function that I gave to the setTimeout, and just giving it the delay. And then I'm returning the task. So pretty much, this allows me to track when this asynchronous operation was done, and I can kind of do things when it completes and when it starts. So I hopefully by now you're kind of understanding how Angular is using this. Basically, whenever we're having an asynchronous operation, Angular increases a counter, and whenever the asynchronous operation completes, the counter gets decreased. And whenever the counter is set to no and something happened, Angular just triggers a change detection, and it goes to all the components and just triggers a re-render on them, if there are certain changes, of course, depending on the strategy. But what if we want to clear the timeout? Here, as you see, we are kind of returning a task, right? I mean, how are we going to clear it? Well, why not we just, for example, create an ID variable up there and just get the ID that is returned from the original timeout. And we get the real clear timeout, and basically the other thing that you can pass to the schedule macro task is a callback that is going to be called whenever we clear a macro task. Okay, that's cool, but oops, I skipped a little bit, I think. Yeah, but aren't we just returning a task? We're still not sure how we're going to clear it. Well, there's not a problem. I mean, we can kind of monkey patch the clear timeout function, and we can just say, okay, whenever the clear timeout function is called, we just want to get the current zone, and then we just want to call cancel task and just give it the task that we want to cancel, which will automatically trigger the callback that we put on the bottom, and this will clear the timeout. So pretty much we are changing the whole the base of our environment to work like this. Okay, yeah. Well, task summary, we have to understand we can schedule micro tasks, we can schedule macro tasks, or basically all kinds of tasks. We can schedule them in our zone. And we can also intercept this task scheduling by using these hooks that we saw. And here I also put a link. If you click it after the presentation, you can also see the different tasks life cycles. This is from the repo that was used for maintaining zone.js, but as you see, it is currently archived. So actually, zone.js is currently managed inside the Angular mono repo, but there are still useful documentations here, and yeah, don't be scared to just look at them if you're interested in the framework. So, why the interception API is so confusing? Well, I told you we cannot just use the simple techniques. We just need to communicate with those delegate methods that we have outside given to us from zone.js. So pretty much now I'm going to walk you through the demo that I developed, and hopefully you're going to see how this whole thing is working. So what do we have here? I just have a standard setup for a web application. Inside this web application, I have Webpack configured. I have TypeScript as well. So that means that I can use certain functionality that TypeScript gives me. And this functionality is, one of the functionalities that I can use is creating decorators. So right here, I have a file. I'm not sure if you can see it. Maybe I'll zoom in a little bit more. Is this okay? So right here, I'm creating this decorator called component, and it accepts this configuration object. And pretty much I just put a selector there and mode for the shadow DOM that is going to be created for our custom component. And of course, this is a factory function, so I just return the real decorator, and inside the decorator, I'm using the old way of extending a class. Pretty much I'm creating a constructor function, getting all the arguments, and just passing it to all the different classes that I'm extending. And I'm also creating a shadow DOM, so this means that whenever this component gets created, I create a shadow DOM, and I also attach a detect changes function. And inside it, as you see, I'm using a render method that is from lit.html. So lit.html is a really cool library. It gives you kind of a way to create, easier create templates. So if you have used web components, basically what you use, or if you used, for example, Vue.js, you use the template tag, right? Well, here, I mean, we can use a template tag as well, but it's very hard to manage the changes to reflect them on the template. For example, if we have a list or we have a value, we have to kind of query selector this, for example, element and change the value, so it's really annoying. And lit.html helps you with this by basically using the JavaScript tag functions, and it's really cool because it remembers all the places of your dynamic content, and yeah, it's very optimized for re-rendering templates. So basically what I'm doing here is called the render function, and I basically say that each component is going to have a render method that is very, you'll see that it's very similar to the render method that we have in React applications. So pretty much we just get the template from there, and we kind of render it like on this shadow route that we have. And I'm also, whenever I create a component, I want to be able to kind of have a reference of it. And here, I'm actually using the zone to keep all the components that I have in my application. So this is something that is not done in Angular. In Angular, we have the Angular compiler which compiles our application. And basically, whenever the browser loads, Angular actually builds the whole application and can have a reference or even like a tree of all the components that are connected to each other. So it's much, much better, and it's much more optimized. But here, because we're just counting on the browser to be able to create our custom elements, there is not a way that we can actually, or at least there is not an easy way that we can actually collect all the components in one place and, for example, trigger the change detection when something happens on the API. So here, I'm just going to use the zone. And here, I just do the usual stuff. Basically, I extend the prototype, and I use custom elements define this component, the one that I just extended, and for this selector that we're going to see on the page. So let's see our app component. In our app component, as you see, it's very simple. I gave it a selector. This is going to be the selector that the browser is going to look for inside our HTML. And whenever it sees this HG app, it will automatically construct this web component. So when this web component gets constructed, this render method will be called, and basically we're going to create these two other components that are called HGCounter and HGUserList. So let's see how they look. The counter is pretty basic. As you see, it really looks something like Angular mixed with React, because we have the render method, and the render method is returning something like that is similar to JSX, but is just like the default JavaScript template strings. And inside, we just use this to get all the properties that are on the current instance, and we just render them. And for example, the user list, it's a little bit more complicated just because we are using the connected callback. This is something similar, for example, if we're talking about Angular, it's something similar to ng-on-init, or if we're talking about React, it's something similar to component mount. So whenever this component is attached to the shadow, to the DOM, we basically fetch all the users, and we also have a reload button on the bottom that we can press if we want the users to get reloaded. And the syntax here I'm not going to explain because it's obvious. Okay, so where is like the whole thing happening? Well, it's here in the main file. In the main file, what I have this bootstrap method, and it's constructing this app zone manager, an object that I created above it, and it's calling a method ignite on it. So let's see what this does. Here, as you see, I have some private properties. I have this counter, like I have a setter and getter for the counter, basically because whenever the counter is 0, I want to iterate over all the components that I have in my, for example, application, and I want to trigger the change detection. This is the only reason why I did this and this private. And I have some other Boolean flags, but I'm not going to get too deep into why I'm using it. They're just certain operations that are happening when our application is loading, and I just want to filter those. So in the ignite method, as you see, I'm just creating a zone spec, something that we saw actually in the slides, and we're saying here, we can omit the on-schedule task because it's not very useful, but here on the invoke task, we are going to say, okay, whenever we are invoking an asynchronous operation, we want to increase the counter, and whenever this asynchronous operation finishes, we want to decrease the counter. And as you know, the only way for us to understand that, the only way for something to happen in the browser is through asynchronous operations, right? So this captures all the asynchronous operations that they exist, and our application knows if it needs to re-render or no. And here, basically, we say, okay, I want to fork the current zone, which is the root zone. I want to give it this spec, and I'm going to say, okay, I want to run. Run guard is the same as run, but basically it has an extra try-catch block that spits out errors, and I say, okay, I want to run this import, which is my application. And after we run this in the browser, we're going to see this here. So, as you see, I'm not doing anything other than just creating components, and this small code that I wrote is actually managing the whole re-rendering of our application. So whenever I'm clicking here, as you see, I didn't have any code inside my components that is basically not fetching, but re-rendering the UI. Everything is controlled to this bootstrap method that I put there. And same here, as you see, we're doing fetch requests. They're really fast because obviously the internet connection is very good. But our application knows that something happened, and we can kind of react to that change that occurred. So zone.js is really, really useful, and I'm talking about it here just because if there are any people who are interested in developing such stuff, to get in touch and maybe discuss like how this can be used in our project that we're working on in our daytime. So yeah, hopefully there are people who are interested in this. It's really cool. So yeah, we saw how we can create a custom change detection, and some additional resources that I found useful. For example, there is a similar library called async listener that is for Node, but you can actually use zone.js on Node as well, so you don't have to do something different. And there is this library called vzone. It basically uses zone.js to create these visualizations. So pretty much you can see all the zones that you have inside your application. It's very useful for debugging. I still haven't used it, but I'll definitely try it out since we're working on this module that I said for our applications. And as you see here, it's not connected to Angular, it's not connected to Vue. You can use it with React, you can use it with plain JavaScript, you can use it everywhere. So yeah, just very nice. And yeah, pretty much this is my talk. Hopefully it was useful to you. all the source code is going to be uploaded on my GitHub account. And yeah, if you are interested in like what I do, you can follow me on Twitter. Pretty much I do a lot of speaking, a lot of open courses. So I'm actually thinking of creating a course that we're creating a small library, for example, something like Angular or React that helps us create component-based solutions for the web. And yeah, thank you all for coming to my talk. We're going to have some questions, or
yes, let's try to run a couple. We don't have anything in Slido. First of all, thank you for the talk. This is Ilia. As he mentioned, he's doing a lot of talks. Be like Ilia, and don't be shy not giving talks. We need more speakers in Bulgaria, so everybody invited. Any questions for Ilia? Anybody that wants to ask either through Slido or asking him over here?
I'll be around, so if you don't have questions in the moment, you can ask me when we get outside, but yeah, I would really love to talk to any one of you about it.
Yeah, something that you were promising is that Zone is actually also enabling a lot the testing. So this would be also cool to be prototyped in the demo that you've shown, how you meant with testing. Obviously, you wouldn't be able to do all that in the presentation, but probably it will be useful for when you're open sourcing it and giving us access to it, if we can have some tests.
Course.
Yeah. Any questions, anybody?
Sorry if the talk was too complicated for you. I just really like to show people certain things and kind of fetch their interest so they can just start digging and start experimenting. So yeah, I kind of like to do kind of more technical talks.
I'd actually appreciate it because we would also like to balance off more techie and more managerial kind of level. If no questions, as Ilia said, he will be around. Not like most of our speakers only for the day. He's around in Bulgaria for all year round, so don't hesitate to get in touch with him. Join Angular meetup, join GDG, and be also in touch with Ilia and be Ilia more often. Thank you, Ilia.
Thank you, guys.